Hi, everybody. Thank you for joining us. We are about to start our WOM Compact Wellhead Overview webinar. Tom, you're ready?
I am.
All right.
Okay. Thank you, Wendy. I'd like to thank everyone for joining us today. I hope everyone can see my screen there. My name is Tom Williams. I'm the product line manager for Wellhead Frac and Flowback for Worldwide Oilfield Machine. And today I'd like to talk to you about our compact wellhead and a brief overview of the product line and installation and a detailed installation procedure of it. This is just a brief agenda. We'll go over, for those of you who don't know who WOM is, we'll go over a brief overview of the company. We'll look at the differences in the product family of the Compact SP Wellhead. We'll look at the features and benefits of it, with a highlight on the WOM Quick Connector for the riser or the BOP. We'll look at some different developments within the SP product line as far as metal-to-metal sealing, and we'll look at that. We'll go through a full animation of the running procedure for the wellhead, and then we'll end with a couple of product photos, and then we'll have a question and answer session at the end. So for the people in the audience who don't know, WOM or Worldwide Oilfield Machine was established in 1980 with only 5 employees in Houston, Texas. Now today, WOM employs over 2,500 employees in 9 countries, with our newest facility in West Texas or Midland, Texas. We currently have 26 global patents on products like wellhead, production trees, gate valves, ball valves, chokes, blowout preventers, choke manifolds, and other offshore and subsea equipment. I wanted to show this picture on on the left there, and that's a 4/16 20K production tree with Inconel inlays throughout that we recently installed for our customer for a land application. Moving on to for the compact wellheads product line, this is just a brief overview, some points on the features. It is a single piece wellhead housing, and it has a minimal amount of wall penetrations for potential leak paths. And you'll hear me say potential leak paths just simply to note that the less penetrations you have in the body or the housing of the wellhead, the better. You'll notice in the picture to the left, you'll see a blue hanger at the bottom, a green hanger, and a yellow hanger, and that's what we call 2 or 3 stages. So in this case, we'd have a 3-stage wellhead housing. It's available in 9-inch, 11-inch, 13/5/8 inch, and 18 3/4 inch in rate and pressure ratings of 5,000 or 10,000 psi. Since we're using fluted mandrel hangers to land the casing, there's minimal time to wait on the cement cure, and we can move forward and land our pack-offs through the rig floor with an internal latch. And so there's no lockdown screws or lockdown pin penetrations. Again, the lower or the lower amount of penetrations in the housing leads to less chance of a atmospheric release. All of those hangers are landed in the wellhead without taking the BOP off of the wellhead. So once the BOP lands on the wellhead, it stays on throughout the duration of the drilling, which is a pretty arduous task in terms of time and effort, and not to mention obviously a safety factor of getting underneath the BOP stack. By leaving the BOP stack on the wellhead for the duration of the drilling, we take all those factors out. It's designed to the latest edition of API 6A, it's the 21st edition, with a product specification level or PSL from 1 to 4, temperature rating from 0 degrees Fahrenheit to 350 degrees Fahrenheit, with material classifications from sweet service, AA trim, all the way up to severe sour service HH trim, which would involve Inconel. This is just the product line tree of the SP Compact Wellhead group. We have the Type 1 and Type 2. The Type 1 implements a latch ring lock mechanism, and it uses elastomeric seals and MEC seals, or metal encapsulated seals. We also have the Type 2 or SP2, and it has a load ring lock mechanism. And I'll talk to you briefly about that. And they use both elastomeric, MEC, and it does have the capability to implement metal seal. Now, the difference between a latch ring lock mechanism and a load ring lock mechanism is simply the load ring lock mechanism allows for multiple strings of casing to be loaded onto the string below it. Whereas on the latch ring or in the Type 1, you would have its own independent load shoulder. So you'll see there at the end under the description of Type 2, says the lock ring transfers the load to the wellhead. And we'll show you what that looks like during the 3D animation. This slide just kind of briefly summarizes the benefits from the features out of the wellhead. Again, it reduces the installation time in a number of ways. All of the mandrel hangers are run from the rig floor. There's no one working in the cellar, in the red zone, around high pressurized vessels. There's no hot work or welding because all of those casing hangers are mandrel style and not slip style. Again, it reduces the amount of leak paths in the housing. It saves on rig space because it is a compact system. Because it is a one-piece system. It reduces the rig cost because you're able to release the rig at a much faster pace than a conventional system, because you're able to move forward without waiting on cement and disconnect and reconnect the BOP after every stage. Since those rig workers and field service technicians are not working in the cellar with hot torches under suspended loads in confined spaces, the safety factor goes through the roof. All the workers are working on the rig floor in a much more safer place than the actual wellhead cellar. And it's versatile. And versatile in the fact that if in the scenario of one of the mandrel hangers does not land completely out onto a load shoulder, that we have the versatility built into the design where we could run contingency hangers in that spot and move forward the operation. This is just the explanation of the installation times between a conventional system. The column on the left and the column on the right shows the SP2 compact. The difference in setup hours or installation hours is roughly 25 hours, which equates to about a full working day of rig work. And so that alone will allow the operator to release the rig a day early, knowing that the rig rates, they vary from market to market, but several thousands of dollars a day. That in itself delivers on some pretty big cost advantages. The picture on the left here on this slide shows a standard conventional wellhead in 13 3/8, 9 5/8, 7-inch and 3.5-inch tubing. The same wellhead is shown on the right hand side in an SP2 configuration. You'll notice in those red boxes, those are the number of times that the BOP will be connected to the wellhead. Notice that there will be 3 of those times done on the drawing on the left, and only just once on the right. So the potential for leak paths is basically cut into it cuts down to 1 versus 3. The same pictures here now just showing heights. 82.5 inches for the conventional system, 53.5 inches for the SP2. Again, everything is more compact and more accessible under the rig. Some specific details here. This is an 18 5/8, 13 3/8, 9 5/8, 7 and 3.5 inch casing program. You'll see the top end of the housing has a WQ connector or WOM quick lock, and that's available in 11 inch 5, 11 inch 10, 13 5/8 5, 13 5/8 10, and 20 3/4 3. That allows for the quick connection of the BOP or Christmas tree or tubing head, if just depending on the operator's operation. Moving down to the pack-offs. The pack-offs for the different casing strings are identical, meaning you wouldn't need several different types or different sizes of pack-offs that act in the same manner. You'd have the same, let's call it assembly part number for both annulus sizes. And again, this little inset drawing here on the right shows the integral lock ring with the latch ring shown in red. So you can see, yeah, right here, that's the latch ring that engages the wellhead housing in orange by driving this blue mandrel down. We'll show that in more detail again during the animation. This slide just highlights the WQC or the WOM quick connector. This is a superior alternative to an API flange in the fact that it offers faster makeup during drilling. Instead of having an API flange to flange connection here, we just have a hub connection with a segmented ring in yellow there that's driven in with these tan locking pins, and I'll show you that in the next slide. We can make up that connection in roughly 15 minutes with a pneumatic impact wrench. Again, this is done prior to the actual main drilling of the wellhead, so or of the other casing strings. This clamp will, or this WQC will engage a ring gasket in the API 6A flange, and we can perform a test on that ring gasket and make sure that it's integral. If you were to compare the same size of 13 5/8, 5,000 pound WQC versus a flange, 15 minutes versus 2.5 hours, if you were to do all of the full per spec torquing recommendations. Here I'll talk about the feature development of the metal-to-metal sealing components. Metal-to-metal sealing is used when you have higher temperatures, higher pressures, and just highly corrosive environments. Those seals are located in all the major sealing areas. The areas here, if you follow my mouse on the screen, this is a straight bore metal seal that connect between the tubing hanger and adapter. So the main production, the fluid production here will pass over this metal-to-metal seal, and it also backed up with elastomers here. This seal here is in the center is a rough casing metal seal that will allow for metal-to-metal sealing onto rough casing if there was an instance for that. And then here, this just shows that same type of metal seal shown in the shop. Okay, so here's the animation that we'll go through. It'll start with a component description, and then we'll actually go through the animation for the installation. Okay, so here we have a conductor casing, and we have a landing ring in orange. Inside the landing ring, we have a mandrel hanger, or fluted mandrel hanger, the blue piece with suspending that casing. The SP2 housing is loaded onto that mandrel hanger, and it suspends its casing strings and tubing strings. This is the pack off with a metal to metal seal on the bottom end. And then moving upwards, we look at a WQC style tubing head adapter there with a tubing hanger, activation ring, and hold down ring with a straight bore metal seal ring. And of course, the tree assembly is above the tubing hanger. This is the installation process here, where we actually go from step by step from the bottom. So that's you're inside the cellar there, and you have the large conductor casing, and you simply hand set that landing ring on it. The pressure inside of that casing is not going to be more than 500 psi, so those O-rings are more than enough of a pressure rating to take inside of that casing. A test is done to ensure that that is integral. A drilling adapter is driven over that landing ring and set in place with those set screws. A pressure test is done to make sure that the drilling riser is integral to the landing ring, and then we go to drilling for the first string of casing. On the rig floor, the blue fluted mandrel hanger there is threaded onto the casing hanger, or that's done in the shop, and then it's all picked up with this gray running tool in the derrick and connected into the casing string. Casings run into the hole just like normal, and that hanger lands into a shoulder into the landing ring. And of course, that hanger is cemented in place. Once the cementing operation is done, the tool is backed off of the hanger and pulled out of the hole. That time, the drilling riser can be detached, and then we can move forward with the full-blown SP2 housing that's run on a running tool and onto that mandrel hanger neck. Those connecting pins engage that mandrel hanger clamp and engages that ring groove, or that ring gasket, into that ring groove. A new ring gasket is put on top, and then the BOP quick connect, or the WQC, is put on top of the wellhead housing. Once again, those locking segments drive that segmented ring into the wellhead housing, and then we pick up our BOP test plug, and we pick it up and put it through the BOP and into the top bowl of the wellhead housing. Pressure is put onto that BOP test plug to ensure that the BOP and wellhead connection is integral, and that's when they can do the test on the rims. That same tool is flipped upside down on the rig, and now it is used as the long wear bushings running retrieval tool. That tool simply jays into the wear bushing, and it's run into the hole. Once it's set, the tool is backed off of the wear bushing, and we go to drilling for the next string. Again, that wear bushing is a sacrificial tool used to protect the wellhead sealing surfaces during drilling operation. Once the hole is drilled out, the running retrieval tool will come and pick up the long wear bushing and pull it out of the hole, that sleeve. And the next casing hanger, or the fluted mandrel hanger in blue, will be threaded onto the casing string, and it is run into the hole with its running tool there shown in gray. That mandrel hanger, the blue mandrel hanger, will land on its load shoulder down in the housing, and that casing will be cemented in place. Once cementing is complete, that tool will be backed off of the mandrel hanger and that will be pulled out of the hole. Next operation is a very important part of the SP2 family is the wash tool. This tool allows us to confirm that we've completely washed all of the sealing surfaces that the pack off will engage and ensure that all of those surfaces are clear of any debris of cement, drilling, cuttings, any type of debris that was left during drilling and cementing, so that we can get a good seal for our pack off and our latch ring. This is the pack off in yellow and it's running tool in gray. It's picked up on the rig floor and driven down through the VOP and into the wellhead housing. So we'll use pressure to engage the tool and set the elastomer part of the pack off. You see in black there, those black seals. We'll go down and do a quick pressure test on those seals to make sure that those were not damaged during installation and bleed off our pressure. We will then do a rotation movement to engage the latch ring into the housing, and then we will test the metal U-cup seal that's shown at the bottom there in white. And for added security, you can simply look through the upper outlet to ensure that the pack off is completely landed out onto the hanger. Once all those verifications are complete, the tool is backed off of the pack off and pulled out of the hole. Next, we'll drill out for tubing in this scenario. So we'll go back to using the wear bushing running retrieval tool to pick up the short wear bushing. Short wear bushing is landed in the upper bowl, and the tool simply jays out of the wear bushing. Again, the wear bushing is very important in the fact that it protects the sealing surfaces during drilling, especially when that drilling pipe could Kelly whip and possibly damage those areas. Once drilling is complete for the tubing, the wear bushing is retrieved with its tool by simply a J operation. Again, the wash tool is run to ensure that that newly drilled hole didn't leave any cuttings or cement, or excuse me, cuttings or debris in that area. And we run it as much as so that we have a clear water coming out of the outlets. Next, the tubing hanger in green is threaded onto the production tubing. And it's picked up into the rig with its running tool there in gray. It's run down into the wellhead housing, and we'll move forward with setting its latch and seals. We'll apply a pressure test on the elastomers shown in red. That's just a depiction of pressure. Sure that those S-seals are integral to the wellhead housing. Once in place, we'll rotate the running tool to engage the activation ring, which will drive the segmented lock ring into the wellhead housing. Once in place, the tool will be backed off and we can go into setting a back pressure valve or two-way check valve there. Once that's in place, the hanger is set and the BOP is no longer needed at that point. that's the straight bore metal seal that connects the ID of the tubing hanger into the ID of the tubing head adapter that's coming up soon. This is simply a hold down ring that makes sure that the activation ring does not back off. And it has some lock screws in it to ensure that it does not back off completely. Then next is the tubing head adapter and tree that fits over the SP2 housing, engages with those locking hubs. The void is tested to make sure that that area in red is again integral to the new connection. The metal to metal seal is tested. And then finally, the upper tree assembly will be attached to the tubing head adapter. Okay, so that was the installation procedure. Here's some nice pictures of recent FAT or factory acceptance tests that we performed. On the left-hand side, we have the pack-off overpull test, showing that we can pull the pack-off to a set number of PSI determined by our engineers. You'll see the segmented ring there in stainless steel. You'll see that chrome-looking steel ring there. That's the actual segmented ring that engages the housing. This is the SP2 wellhead that is set into its lock ring, into its landing ring, And then finally, the test to set the tubing hanger inside of the housing. And then finally, here's the same wellhead that was installed. You'll see on the picture on the left, that is the landing ring with a line pipe connection coming off for drainage. You'll see that large or that ball valve here. The picture in the middle shows, you can't really see the SP2 wellhead, but you can see the BOP that's over the top of it right there. And then finally on the right, you see the completed SP2 landed in its landing ring, in its landing ring, fully set and operational. With that, that's all I have today. I appreciate your time, and we'll look at some questions. I'll bring Wendy back on, and maybe we can moderate some questions.
If you would like any questions answered, feel free to send us your question. If not, you can definitely send an email to Tom, and he'll answer your questions. His email address is right on the screen. It's tomw@womgroup.com.
Okay, well, thank you, Wendy, and I thank everyone for joining us today. Again, like Wendy said, if you have any questions regarding this product or any of the wellhead frac or flowback equipment that we offer, I'll be more than happy to assist you. Again, thank you for your time, and we look forward to talking to you soon.